Welcome. In this video we start Unit 13, Polynomial and Rational Functions. Here we are in Day 1, graphing polynomial functions. This is section 5.2 from the book, and we'll just really focus on Objective 1, graph a polynomial function. Here's an example. So here is a polynomial function and what its graph looks like. In general, we won't be given the graph. We're given the function, but then we have to use some different characteristics of that function to figure out what the graph looks like. We'll consider the end behavior. So in this case, both ends of the graph finish upward. We'll look at the y-intercept. So how high does the graph actually get when it crosses the y-axis? We'll talk about the x-intercepts. So where does it touch or cross the x-axis? We'll think about real zeros and multiplicity, so that not only where does it touch, but how does it touch the x-axis. And then we'll talk about turning points. In this particular example, it looks like there are 1, 2, 3 turning points. All right, so we'll do some different examples. We'll look at all these different characteristics and see if we can get a good sense for how to graph polynomial functions. Let's talk about the end behavior of a polynomial. This is also called the behavior of f of x for large values of the absolute value of x. If you imagine an x-axis, x can get really big to the right, or if x gets really negative to the left, in both cases, the absolute value of x is getting larger and larger and larger. So the end behavior of a polynomial, also called the behavior of f of x for large values of absolute x. Well, first of all, we have to find the leading term of the function. For example, what is the leading term of this polynomial? I look for the biggest power of x, and I take that biggest power of x together with the coefficient in front. So I get 8x cubed in this case. How about this one? The leading term of this polynomial. Well, I do need to do some multiplication. I have a negative out in front, and when I expand this factor, I'll get an x squared out. When I expand this factor, I'll get out an x cubed. And x squared times x cubed is x to the fifth, so I get negative x to the fifth power. That's my leading term. Now, it turns out that the end behavior of a whole polynomial is the same as the end behavior of the leading term. So all you have to do is figure out that leading term, and that'll tell you how the function behaves. Well, if the leading term has even power, then that's when either both sides are up or both sides are down. And when the leading term has odd power, that's when there's a split. One is up and one is down. Now, you can tell which is which by looking at the coefficient. If it's a positive coefficient, then it ends going up. But if it's a negative coefficient, then the graph ends going down. You can see that there. Let's do a little bit more on this, just another example. What is the end behavior of this function? Now, I see the graph of it, but let's determine without having to look at the graph. Well, the leading term, okay, there's a coefficient of 1 out in front, so I don't need to bother with that. When I expand x plus 1, I get x squared. When I expand, oh, I don't have to expand, x minus 1, I just get x. And when I expand x minus 3 cubed, I'll end up with an x cubed in there. So that's x to the 6. That is my leading term. And as a graph, x to the 6 looks like that. So it's up on the left and up on the right. And you can see that general behavior on the main graph. It's up on the left and up on the right. How about intercepts and zeros? How do I figure out the y-intercept? On the graph, it looks like it's a little bit more than 20, but how do I actually figure out what it really is? This is where you plug in 0 into your function, because 0 is the x value. So f of 0, let's say I plug in 0 for x, I get 1 squared times negative 1 times, and then I get, looks like negative 3 cubed. So altogether, that looks like positive 27. And so that's what that number is. It crosses the y-axis at 27. How about the x-intercepts? So on the graph, it looks like negative 1, 1, and 3. Can I be absolutely sure? So let's go to the actual function, and I want to know, where will the factors be 0? This first factor is going to be 0 if x is -1, so -1. This second factor will be 0 if x equals 1. And the third factor will equal 0 if x equals 3. So that's what tells me my intercepts, -1, 1, and 3. Now, the intercepts come with multiplicities. So intercepts, zeros, kind of the same thing. The zeros are -1, 1, and 3. Those are the x values that make my function equal to 0. Now, -1 is a 0 with multiplicity 2. I get this from looking at the power on that factor. 1 is a 0 with multiplicity, well, there's really like a 1 up there, so that's a 1. And then 3, that's a 0 with multiplicity 3. So how does the multiplicity affect how the graph behaves around the x-axis? At a 0 with odd multiplicity, so that's there and there, then the graph crosses the x-axis. You can see at 1, the graph crosses the x-axis. At 3, it crosses. Now at 3, it sort of becomes flat as it crosses. That's because 3 is greater than 1. When I have multiplicity 1, it just crosses straight through. Otherwise, if it's not multiplicity 1, then it kind of flattens out a little bit. Now, at a 0 with even multiplicity, the graph touches but does not cross the x-axis, and you can see that there. And turning points. So turning points depend on the degree of the polynomial. In this first case, let's see, the degree, if I expand it out, I'll get x squared times x cubed, that's x to the 6. So the degree is 6. And if I count turning points, 1, 2, 3, it looks like there are 3 turning points. In the second example, let's see, my leading coefficient, my leading term is 1/2, and then I'll get an x. I'll have x to the 4, and then just x again. So that's 1/2 x to the 6. So the degree is 6 again. How many turning points? 1, 2, 3, 4, 5. There are 5 turning points. And in this last example, it looks like the leading term is -x to the 6. So again, degree 6. And how many turning points? It has just 1. So in all 3 cases, the degree was 6. But it looks like I could have 3 turning points, or 5 turning points, or 1 turning point. So the general rule, in fact, is this, that a polynomial of degree n has at most n minus 1 turning points. So with degree 6, I can have at most 5 turning points. All right, let's put all these ideas together with an example and see what we can do to graph the function. F of x equals -2 times x plus 3 times x minus 4 cubed. What is the end behavior? Well, I need to figure out the leading term. Leading term. That'll be -2 times x cubed. And so that is -2x to the 4. So x to the 4 goes up on both sides, but I have a -2 there, so I'll make it go down. So it goes down on both sides. What's the y-intercept? Let's see, f of 0, that'll be -2 times, and I plug in 0 for x, I get 3. Plug in 0 for x, it looks like -4 cubed. And that works out to 384. How about the x-intercepts? So from this factor, x plus 3, there's an x-intercept at -3, and x minus 4 tells me there's an x-intercept at +4. At -3, it has a multiplicity of 1, and at 4, it has a multiplicity of 3. And the maximum number of turning points. Well, looking back at my leading term, the degree is 4, so it can have at most 3 turning points. So if I make a graph, very roughly, here's what I'm thinking. X-intercept at -3, x-intercept at +4. It has a y-intercept of 384, so way up there. So this is not to scale, 384. Now, the end behavior is down on the left and down on the right. So it'll come down there and it'll end down like that. At -3, the multiplicity is 1, so the graph crosses straight through -3. And then somehow it comes up, hits the top there, it comes back down. At 4, the multiplicity is 3, so it'll cross through, but it will curve nicely down there and then continue through. Alright, so something like that. Alright, let's see how this compares with the real graph. There we go. Pretty good. Alright, here's one for you to try. Pause the video, give this your best try, and then when you are ready to check your work, start it up again. Go to it. Alright, here's what we have. The end behavior is, well, it's x cubed, so the end behavior looks something like this, down on the left, up on the right. Y-intercept 18, x-intercepts -2 and 3, multiplicity is 1 and 2, degree is 3, so maximum of 2 turning points, and the picture looks like that. One more example. Again, pause this thing, try, and then start the video again to check your work. Alright, let's take a look. So, the solutions to all these on the left are presented. See how you did. One thing to watch out for, there are no zeros in this third factor. You can't get any x so that x squared plus 5 is 0. That would you'd need x squared equals -5, but you can't have that. And the picture looks like that. Alright, so there you go. So when graphing polynomial functions, it's important to think about the end behavior, intercepts and zeros, multiplicities and turning points, and once you kind of get all that stuff, it helps give you a good idea for what the graph looks like. Okay, and we'll stop there.